Now we apply the first law of thermodynamic at constant volume. Consider a gas enclosed in a cylinder having a piston. Suppose the internal energy of the system is E1. A quantity of heat Q is given to the system and work W is done on the piston to keep it in its original position. During these operations, the internal energy of the system changes to E2. The change in internal energy delta A is given by E2 minus E1 equal to delta E is equal to Q plus W. Delta E equal to Q plus W. This is the mathematically form of first law of thermodynamics. If W is pressure, volume, work, then the above expression assumes the form delta E equal to P delta V. When the volume does not change, mean 0, then delta E equal to Q. This shows that a change in internal energy of system is equal to heat absorbed by the system at constant volume QV. In other words, the heat supplied in a bomb calorimeter is utilized in changing only the internal energy of the system. Now we apply the first law of thermodynamics at constant pressure. According to first law of thermodynamics, delta E equal to Q plus W. If W is pressure, volume, work done by the system, then W equal to minus P delta V. Now delta E equal to Q minus P delta V. Let at constant pressure QP be the heat absorbed at constant pressure, then we get equation QP equal to delta E plus P delta V. We know that difference of final and initial energies are called delta E, and the difference of initial and final volume we get delta V. It means QP equal to E2 minus E1 plus P V2 minus V1. As we know that the H equal to E plus PV. H is the enthalpy of the reaction. This is a new function that is called enthalpy, that is the heat content that is introduced to express thermal changes at constant pressure. Now we get equation QP equal to delta H. QP equal to delta H. This shows that heat supplied at constant pressure is utilized in changing the enthalpy of the system.